I'm going to talk a bit about a project we did with Bowmer and Kirkland up at Masterton Crescent. So the site is in the west end of Edinburgh. You can see the Google Maps screenshot of the site. So it is, I can't use the pointer, but it is the structure adjacent to the railway and bordered by the road to the south. So you've got Masterton Crescent to the south, the railway line to the west, and then the western approach road to the north of the site. And it's pretty obvious that there is quite a height difference across the site there as the road goes under the railway and then the western approach road goes over both of them. So there's from south to north, quite a height difference across the site. I'm going to talk about two of the more interesting sections of the work on the site, which was the tower crane foundation, which was a little bit non-standard given what was around it, and the embankment support for the Network Rail embankment, which was a propped sheet pile wall. So firstly, we'll have a chat about the Network Rail embankment. So prior to us getting involved, the existing structure was demolished and there was an existing masonry wall supporting the Network Rail embankment. This had been secured with some 6F2 against it to prevent movement. The new structure involved the construction of an L wall slightly in from the masonry wall along the Network Rail embankment. And to install that, we were required to provide some temporary support. So as the design progressed, we realized quite how hard this was going to be with the kind of network of ground beams that were being installed and the other constraints on the site. So we elected for a propped sheet pile wall solution. This was for a couple of reasons, mainly kind of the deflection limits on the actual Network Rail embankment and the ground conditions. You couldn't pile very deep, so we couldn't really go with a cantilevered sheet pile solution. And we, quite usefully, we had a collaborative approach with the permanent works engineers, allowed us to use their ground beams that were pre-installed before the sheet piles to prop off of and kind of give a very efficient solution. So I've got the plan view there, which shows kind of the sheet piles. There was a section of contig walls further up where the cantilever was higher, but this section was elected to go with sheet piles. And then a section showing the construction sequence. So it was quite an interesting little project, but it kind of solved the solution well and gave something that was both buildable and kind of fairly efficient in the fact that we didn't have to use thrust blocks. The second interesting part of the project was the tower crane foundation. So this is an early sketch of the location of the tower crane. So around the tower crane, we had a contig pile wall on two sides. We had a number of services, so manhole chambers and things that were proposed around there. And then we had further permanent works ground beams to the south of the tower crane foundation. When we started looking at this, we could not kind of carry out a tower crane that fitted in the gap that we had because of the kind of the pile spacing from the contig wall and the other foundations. So we elected to combine this tower crane foundation with the permanent works ground beam to the south, which kind of gave us a solution that was a bit more complicated to design, but it did give us a workable solution that fitted in the space. Because of the extra depth we had to put onto it to get beneath the ground beam, we had to go beyond what the contig pile wall had been designed for. So we also had to deal with some temporary propping to actually allow it to be installed. And that can be seen in this picture of when we went on to inspect it. You've got the propping just up above it to provide some temporary support until the base was actually cast. So it was, yeah, again, another interesting little project that had a lot of tight site constraints and made a bit of a challenge. And finally, we've got a bit of a video that Bowmer's made, and this shows the construction as it went on, well, at least the kind of ground working side of it and their work on the site. So at the start, you can see them looking at the central kind of core and ground beams in that area prior to them doing the propping. So the railway is to the left of the site and the tower crane base was on the back right hand side. You can just about see the propping going in there. And you can see the sheet piles going in now for the embankment and the propping, and they quite quickly got the wall constructed, backfilled against it to allow them to remove the propping. And yeah, the tower crack went up fairly quickly. So that was kind of our main involvement in the start of the project. So I'm going to hand you over to Josh now, I think, for a bit on a bridge demolition scheme. Wow.
Thank you, Dave. It's just next one. There we go. Right, back one. Okay, so thank you, Dave. In a similar vein to Dave, I'm going to talk to you about a couple of projects or key project highlights that I've had in my year. I've had the opportunity to work on some fantastic projects, but I'm just going to bring you a couple. The first of which is the Heartlands project for HS2. This covered the demolition of 100 metres stretch of road bridge in Saltley, which is near Birmingham. The bridge was removed over 4 weeks between August and September to make way for the northern section of the HS2 phase 1 route between London and the West Midlands. The work was carried out by Jonathan Regeneration, and they were the demolition contractor, and they were working for the main civils contractor, who was the joint venture of Balfour Beatty and Vinci, BBV. The subcontractors were Podtrack, who looked at protecting the rail tracks, but also included us, who we provided the temporary works design for the demolition works. You can see the bridge there on the right, and it had 3 spans, the central span being over the railway line. At Andon, we were acted as the demolition specialists, assisting John F. Hunt with the demolition methodology and the temporary works design, and we designed the track protection which went over the railway tracks, which was constructed of a layer of geotextile over the rails, and then some fill core blocks and then timber mats that allowed excavators and plant to work over the track without damaging them. We also provided the 3D sequence drawings that assisted the John F. Hunt in producing and describing what it would be, and they also included that into their RAMs. We carried out the bridge stability assessment too, and our philosophy on this was to reverse the construction sequence which was outlined in some of their archive drawings. This was a project where we had quite a lot of archive information, which is not something that we always have the benefit on all projects, but this one we had them, so we were going to put them to good use. And because we had the knowledge of how the original designer envisaged that the bridge would be constructed, i.e. which spans would be inserted and which sequence, that means that we could reverse that sequence, which reduces the risk that's involved with stress changes or support condition changes. That means that part of the design had less risk, and we also proved that the sequence worked ourselves, but it's always a good idea to maintain the established load paths in a structure. We also produced the Form 2.3 that was required for the Network Rail submission. And then another item that we designed was the temporary stability system of the structure that was during the dismantling sequence, which I'm going to just talk a little about here. So one of these systems is shown in, on the right-hand side, and this was required as the head restraint and the diaphragm bracing of those steel beams was removed, and we wanted to ensure that they remained stable whilst they were being prepared for lifting. And the detail was to run a strap from 4-ton bags of ballast up around the flange through a hole in the web and back round to another 4 bags, which was on the other side. And this effectively prevented the tall, skinny beams from toppling over. We also carried out the crane position, which is shown up on the top right-hand corner. And it's worth noting at this point that the pads, because we were operating adjacent to railway, it's requires adding on an additional factor required on top of the outrigger load, which is in accordance with the CPA guidance, which is pictured at the bottom there. So this is a factor which is over and above any partial safety factors that's required for design codes. And the CPA guidance states that the load should be multiplied by a factor of 1.33 to increase the level of safety of the foundation absorbing those loads. And you can also see here where we've shown the lifting sequence and weights, which were then incorporated into the rams. The final stages, once the majority of the structure was removed and the span was taken away from that sat over the railway lines, we had the span 3, which was removed using mechanical demolition methods, so a larger excavator and breaking out the concrete, and then the steel beams were removed using a controlled collapse mechanism with a plastic hinge. So the beam is cut by a burner from the bottom up, and eventually the self-weight of the beam causes the beam to sag onto some pre-prepared debris stockpiles, and then it's processed and demolished. And so that was the theory. We've got a video here which kind of shows the works in practice. So you can see here they're taking out the parapets and the concrete structure by mechanical means. And then once the deck was removed from spans 1 and 2, then we could come in with the mobile crane and start lifting some of the steelwork away. You could see there some of the diaphragm braces between the steels, which provided lateral stability, but they had to be removed to enable the beam to be taken out. And that's the final span coming out there. So now from the bridge demolition to Scunthorpe, and the tale of two chimneys is what I'm calling it today. So that's two chimneys of different construction, and we dropped those in a similar fashion, but it required a different methodology due to their location and construction. The principal, the contractor was the demolition contractor Sam Evans and Sons, and the client was British Steel. Specialist Explosive Services were the explosives contractor for the chimney that was blown down using explosives, and we were the demolition engineers providing the design for them both. So we'll start off with the first example, which is the pull down or push down in this case of a steel stack. The structure was approximately 5 meters in diameter and 56 meters tall. It had an outer shell and an internal liner and had a significant section change at about 5.5 meters above the base, which you can see there in that photo. The section change and the intake pipe, which is coming in from the right hand side, that had quite an impact on what we could do, because this meant that we had no restrictions on the pre-weakening. Therefore, if we made the section and had the pre-weakening higher up, that means we could effectively choose where we wanted the to fell the chimney. We had quite a significant site constraint, which was the ammonia tank, and that's one of those tanks you can see there on the photo as well. That was the principal risk. So we wanted to make sure that we were felling the chimney away from that risk. So our design was based on the justification of the pre-weakening and ensuring that there was enough structure to resist any destabilizing forces, which are principally wind loadings. And then what we do is we break the sequence down bit by bit and check each part of the structure by calculating the section properties of each section at each stage, and a little snippet is shown there. And this essentially ensures that the chimney doesn't come down prematurely. And the trick is to remove enough of the section so that it can be pushed over, but not too much so it blows down in a gust of wind. The structure in this case was pushed down using a grab attachment on the end of the excavator, and this meant that the grab attachment could kind of saddle itself on the profile of that circular chimney shaft and make sure that we could put the suitable force on there, which was pre-calculated during the design, and then induce the collapse. And here's how it went on one Sunday morning. And that meant that all that structure could be processed and from safely from the ground. That's the intent. And so now onto the other chimney, which was a concrete and as much taller than the steel stack. This chimney was 78 meters tall and nearly 1,000 ton in self-weight. It had a concrete outer ring and then a brick internal liner. There was a large hole on one side of the chimney where the flue came in, and this hole was so large that we couldn't avoid it at all. So we had to work with that opening, incorporating it into our pre-weakening sequence. And fortunately, we were able to make it work so that the chimney dropped in the safe zone and away from the live conveyor systems, which were to the west and south of this chimney. And then this chimney was, as opposed to being induced by being pushed over or pulled over, which we saw in the previous example, this one was induced by explosives. So there was a strict preparation sequence involving test blasts, pre-weakening, heel cuts and hole drilling for the explosives. And then again, the design check included the review of the structure at each stage, checking the stability of the different sections and ensuring that the thing remained stable until we blasted out the final section and induced that collapse. And the idea is, once all the planning is in place, the demolition can commence. And the philosophy is that with any pull down or blow down is to get the structure on the ground so that then it can be processed using heavy plant working from ground level. And we want to reduce the working at height due to it being a significantly dangerous activity in the construction industry. So this type of demolition is high risk, yes, but it's for a very short period of time, and controls such as a site-wide exclusion zone, they can be implemented, so that keeps the overall risk much lower than alternative methods, because it's high risk but for a very short limited time. And here's how this one went. It's a short video. So the initial blast to remove that final section of the structure. And then I will hand you over to Angus.
Stop controlling it, Josh.
Yes. There you go.
Good morning. So I'm going to talk to you today about Eggborough Power Station with a nod to Josh's title, which I stole and tweaked slightly. This is the tale of 8 cooling towers, which, as we all know, is better than 2 chimneys. So this was, or this is still a job for DSM, and they use Special Explosive Services as well for the demolition, the explosive engineering on the scheme. And we were the structure engineers, so responsible for checking the structure for the pre-weakening works and making sure it's going to stand up when we want it to, and hopefully fall down when the explosives go off. Hopefully is the word I use, because it doesn't always happen. In this case, it did. Bit of a spoiler, but yeah, it worked. So they tackled them in 2 sets of 4. The first 4 in August and the second 4 in October of this year. DSM are actually demolishing the whole of Eggborough Power Station, but this was the first major bit to get done. Now, these cooling towers have had a bit of a checkered past. There was one, I can't remember which site it was, back in the 70s, I believe, might be in the 80s, where the cooling tower failed and collapsed. Following that, a lot of the cooling towers around the country were actually strengthened. They found that the wind loads around them significantly increased, which meant that the designs that had been completed weren't quite robust enough. So, and I can assure you, when you stand underneath those towers, the wind really does whistle under there, really does cause I think almost like a vortex around them. It's incredibly windy, even on quite a calm day. So, as I said, we did the engineering work on this. The first phase of that was proving you could take out one of the diagonal columns that allowed, and a bit of the lower wall that allowed plant access inside the cooling towers, and strip out all of the grillage, cribbage, which sits inside it, over which water runs to cool the exhaust steam. So that was the first phase of the works. The second phase is to prove that the pre-weakening doesn't cause the towers to become unstable. Now that has 2 parts. The first bit being they do what we call a pre-blast or a test blast that just demonstrates the amount of explosive required to weaken the shell sufficiently. So they'll choose a small area of the structure, and they choose one leg typically on a cooling tower, and they blow it just to prove that they've got the amount of explosive correct, and get an idea of how it's going to fragment, how far fly is going to go, that sort of thing, and whether their proposed protection around the explosives is going to do the trick. SES obviously know their stuff. They've done enough of these now to know with a good deal of certainty what's going to work. But these ones, because they'd been strengthened, and you had the original shell, then you had a grout, before a spraycrete, and another layer of mesh. Again, it was important to check that they actually behaved as we thought they were. The idea with these towers is to blow out 2/3 of the circumference on the side that you want it to fall, and the same with the columns, roughly. You blow those, and then gravity does the rest for you. So this was, I took my sons along to watch this, because it's quite a spectacle. So we all got out of bed nice and early, drove down to Edinburgh. Got some nice bacon rolls from DSM, which was good. And then got to stand there and see this in action, which was quite something. The first cooling towers I've ever been to see blown down, that's for sure. Had a good view. So that was quite an exciting morning. The boys still talk about now. In fact, we got given these special passes to get us onto the site, and Cameron's got it on his bedroom wall still. I think it's a day they're going to remember. But what the most amazing thing about it was, in fact, you can see it if I replay it. You see the flash of the explosives, you see it start to move when it gets going. So you see the explosives, and you don't hear the explosion for quite some time. That was the weirdest thing about it. You'd have thought the distance, how far away you were, it'd almost be at the same time, but it really wasn't. It was quite strange, quite surreal. And then we have the proper video that DSM did, which is a bit more spectacular than that. So not quite that great quality. I think I must have got a low-res version of it. You see all their plant there, including the Super Beast they have, their huge high-rich machine. And this is actually the second one. You can see the first 4 there, which we went to see. This is the second 4 going down. It's always amazing the way the concrete folds up. It's almost like it's paper when it folds up as it comes down. It's incredible. See how flexible it becomes. And interesting to see how one of them actually shears off, rather than 3 of them folding quite nicely. One of them shears off. Yeah, that one. You can see there it is again. That one really shears and folds in on itself, whereas the others don't quite behave like that. It's almost like there's a weak point around that at a high level there. It's interesting to watch how they behave. See it again. And then on to probably the other extreme, so from the heavy demolition that we do quite regularly down to the smaller scale projects that we get involved with. So this is for Waters out of South Wales. Worked with them for many, many years now. And they are on a framework with, I think it's Somerset Council. And the scheme they had was to repair a arch bridge in Masterton. So this bridge was originally strengthened back in late 90s, early 2000s. Clearly something wasn't done properly. Because it was racking itself to death again. Very, very shallow cover over a very small arch and quite a heavily used road. I think that if this road's closed, the diversion is quite a long way around. So it was regularly getting battered by 40-ton Arctics, which was not doing it any favours. So main road through Masterton, and you have what is quite a small and a shallow arch. So you're only talking about 500-600 mil high from the soffit of the arch to the bottom of the stream bed, which meant a traditional timbering option wasn't really going to be that suitable. However, the end section there, you can see how it's on a kind of on a skew here. That bit there was done with traditional timbering, which you can see there. Whereas the rest of it, we went with what I think is a one-of-a-kind solution. So I found these things called Geodams, which are effectively a waterproof teram, that are usually used for stopping for temporary flood control. So if you get these, you fill them up with water, they make effectively a wall from 0.5 metre high to 1.5 metres high that you can use to prevent floodwaters entrance. So they look a little bit like that. So that is a teram that you just literally just pump water into one end of, and it just fills up, and the self weight of it keeps it sitting there and keeps it stable. So I proposed to get one of those and put it inside the arch. The advantage being you haven't got to try and crawl in there and make the timbering. Nobody's got to work underneath it, and it will provide a nice uniform support to the full inside of the arch. And then there's the full sequence of how the works had to be done. So section by section, try and keep the load balanced either side, etc. Do one half of the bridge at a time so they could run plant past the other side, and then reinstate everything. Repeat the other way around. So there you can see the timbering in place on the outer side where it has a bit of a skew, and then you can see there the geodam sitting inside the arch. It's very difficult to get a picture of because of the constraints, but you can see it there inside the arch, filled up with water, and that's putting a pressure against inside of the wall, inside of the arch, and keeping it stable. And there's the back of the arch exposed, so it wasn't in the best of condition, and you can see the road's only 300 mil above the outside of the arch here, the crown of this, at its shallowest point, which is not a great deal for quite a slender arch. And there you can see when it's all being pointed up by the guys from Waters, did a nice tidy job. And then all the road construction was built back in, compacted. Away you go, and now you can go on Google Maps. This was done in November 21, and you can see there the fully reinstated road is back in place and hopefully fit for more than 10 years. But we'll see on that front. I would hope so. But you couldn't even see there was really an arch bridge there. And unfortunately, this arch bridge was listed, so that the cheapest option would have been to have ripped it out and replaced it with a modern alternative, but it was listed and protected by English Heritage, so we had to reinstate it and try and maintain as much of it as we could, which is what drove the whole methodology. Now, the temporary works flowchart we have is probably one of the most downloaded things on our website. And we've been saying for some time now, and Christian will tell you how many times a month he phones me up and says, have you done that flowchart yet? Have you got the new flowchart ready yet? Have you finished the flowchart yet? So finally, we had a bit of a brainstorming session and we decided, you know what, instead of making a massive bulky A0 flowchart, which is what we had done for the new version, the feedback we've had from people was that it was not particularly user-friendly because of the size of it and everything else. Even on a screen, it was very difficult. So we've taken the decision to go with a website. So this will be launched in the new year. But this is just a little video of what it's going to look like. It will be in a members only website. We're not proposing to charge for it or anything like that, but it will be a members only website. This will be the landing page where you'll have the choice of clicking on principal, managing contractor or subcontractor to see which part of the flowchart really fits with what you're doing, because 5975 differentiates between those roles quite heavily now. And there we have, you'll even be able to download the PDF if you so choose to have the full PDF. But the idea is this website will be the point of review and the point of assistance for yourselves. So you can see, instead of having a box on the side, you have these little information tabs that you click on, and up pops the information that we've written there and refers you to the correct clauses of BS 5975. And we feel this makes a much cleaner experience for everybody. You can look at the flowchart if you just want to understand the process. If you want to go into more detail, you've got the information. And if you want to go into full detail, it takes you straight to the relevant clause on the right hand side there of 5975 2019. So the only question that remains is, how long is this going to be current before the new 5975 comes out and we have to do it all again? But that will teach me for not getting on with it, I suppose. So hopefully January, by the end of January, that should be live, and it will be on, what's the website going to be, Chris?
Temporaryworksflowchart.com.
That's the one. So that'll be out in the new year for everybody to enjoy, hopefully. So just a few snapshots, and a big thank you to Jason Liu from Jason Liu Marketing, who's worked with us on this. He's helped us on quite a few schemes now, and he was happy to take on this task of turning a flowchart into a website, and he's done a good job for us. Though he is going to be tweaking the colours somewhat, because I think even he thought they were a bit in your face. So, but he's the man to go to for construction marketing if you need any assistance. And just another snapshot there of the managing contractor option. So a thank you to everybody from Andan who's put together a presentation this year. It is quite some undertaking to do. Once a month's bad enough. When we're doing it once a week, it was a nightmare, but once a month it still comes around too quickly for my liking. But we've all managed it, and thank you to everyone from Andan who's presented this year. It's been another good year for us as a business. I think we've done over 600 projects have been delivered, and that's something that costs 500 quid to some that go over £100,000. So it's been a cracking year for us. We've got our East Midlands office up and running with 3 staff up there. Dave has moved from Aberdeen down to Edinburgh and now has a staff of 3. Josh has continued to drive the Northwest office on. So very well done to everybody at Andum. And we've also done a lot of work to reduce admin and increase the quality of what we produce across the business. And there'll be more to come on that next year in a presentation when we're just about ready to push that out. And as I said, we've done 12 webinars this year that have been quite well watched. That doesn't make any sense as a sentence. I think you know what I'm getting at. That have been seen by quite a few people, and thank you all for coming along and watching. If you weren't there watching us, we wouldn't bother, so thank you. In fact, if you could all stop, then we won't have to do these anymore. But oh, I don't mean that. There you go, that's the offices, just in case you're looking for them. A bit more of a sales pitch you normally get from us, but there you go, it's Christmas. So any questions for anybody on anything